So we'll continue with our Astronomy 1 lecture, Chapter 4, which is about the Earth, the Moon, Sky. Last class period, we learned how to find a specific location on Earth based on latitude and longitude. And next thing was the seasons. We looked at, scientifically, dynamically, what causes seasons on the Earth. So next is keeping time. We'll today look into solar day, sidereal day. We are more interested into solar day. That's more obvious to us than the sidereal day. We'll differentiate between these two in a minute. We'll look into the calendar, why we need a calendar, and later phases of the moon, and tides and eclipses. Yep. To start, historically, from the ancient times, again, we have discussed this from the beginning of this course. Sun, moon, and stars have played a very important role on how we, set our time, day, months, years, and so on. And the measurement of time is, primarily based on the rotation of the Earth, because it causes the rotation of the month, causes the sunrise, sunset, and basically the time the sun rises, that's our that's when the day starts, and the day ends when the sun sets, and so even in astronomical terms, day is the most fundamental unit. And we define day in two ways: the solar day and the sidereal day. Think of you living 200 years ago when you don't have your phones, your calendar, your watch. How do you keep track of a day? I mean, now we have all the mechanical clocks and watches, and it started back then. You may have heard of recent news about the Stonehenge, how it was a monthly calendar based on where the sun rises and sets between those stones. So based on all this information, we finally defined more scientifically what a day is, and a day can be defined two ways: a solar day and the sidereal day, and that's again caused by the rotation of the Earth. Let's pick at this point in space here and draw a straight line, and day one, a straight line where the red one is someone is standing here, and the line joining the sun, so we start at that point. And as the Earth rotates, it also revolves, so it moves farther out in that direction. And so the Earth reaches at that point in day two. And so we can say, okay, from this time, a vertical line, a line joining, the Earth to the sun, we start there, and the next day when the Earth has moved by some distance, and we call that from this length, from this point to that point, as one solar day. But you see this vertical line here, is pointing somewhere out because the Earth has moved a little bit. So the Earth now has to rotate slightly extra time. That's about 4 minutes, or 1/365 of a day, so that we still face the sun, that dotted line here. So the solar day is the rotation period of the Earth with respect to the Sun. We are keeping Sun as the reference. And here, back to the original bottom line here, we can continue that arrow that points to some distant star. And so today at certain time, we are looking at that star, and after 24 hours, Sun will travel some farther out, and same projector straight line, and that whenever we see that star in a straight line, this difference, we call it a day or sidereal day. So sidereal day is measured with respect to the stars. But measuring day in terms of Sun makes more sense because it has more effect in our life, day-to-day life. However, the only catch is every rotation or every day, it takes extra 4 minutes. The Earth has to rotate every 4 minutes or extra 4 minutes every day. Okay. And that has a consequence because we measure our year in terms of days. And so our year is not, so to go around, the Earth to revolve around every day, we are adding 4 minutes. And so that 4 minutes adds up within a year's time. And so it's not 365 days, but it's 364 and almost quarter days. And that thing adds up over 4 years period. You add quarter days every year. After 4 years, it's 1 extra day. That's when we get into, that's what the leap year is. We'll come to that in a minute. And so days and time. Time is also another challenge to understand. One way is the mean solar time. We can always look at the Sun, and whenever Sun is at the in our zenith, top of us, we can call that noon, 12 p.m. But there's a problem with that. Earth is circular, and whenever it's noon time in Dallas, let's say, when the Sun is right above your head, when you are in Dallas, in Arlington, it's not above the head. And so when it's noon in Dallas, it's not noon in Arlington or Fort Worth. So every degree, we move along the circumference of the Earth, we have to have different time zones. So that mean solar time is not practical in that sense. So instead, we set a standard time, and we divided the Earth in 24-hour time zone. So no matter, if you are within this block here, it's one time zone, one standard time. It's more visible here because that division led us to in 1883 to have 4 different time zones for continental US. And so if it's noon in New York, it's noon in Indiana, Ohio, even far out here. Right? I mean, if you had to follow mean solar time, then the noon would be different, but so that everyone can sync their clock, we call that the Eastern time zone. So when it's 5 p.m. here, it's only 4 p.m. It's 1 hour off in the Central Time, and you move 1 hour to the left or to west, it's Mountain Time, and we call all this the Pacific Time Zone. So that we all can sync to one time, we follow these standard time zones, so that we can we can reset our watch only when, you know, the time had changed 1 full hour, not every minute or every second. Okay, so these are the standard time zone. Well, that's the continental U.S. The Alaska is up here, so Alaska has Alaskan time zone, and so is the Hawaii. So there are 6 time zones, including Hawaii and Alaska. And not all countries follow that. For example, China. China, if you look at it, it's big. It passes through 5 different time zones. So the time zone should be very similar to the US, but they don't choose to follow. But it's just one time zone. I guess in that sense, you know, the time and these are also relative things. Just what is comfortable for a human society. You know, we define time, standard time, to fit that human comfort. And so is the date. The day, you know, the Earth rotates, right, west to east. And so sun rises in the east first. So it's already, the sun has already set in the east. And they will reach tomorrow sooner than we in the Western Hemisphere. So today is March 8th, almost noon, but it's almost midnight in the east, or even past midnight, so it's already March 9 over there. We're March 8, they're March 9, they are all 12 hours ahead. And even for that, we had to have a borderline somewhere. And so that it doesn't conflict with people living on the land, we draw this line that goes through most of the ocean between the Alaska and Russia here. Draw that line, and so this part is the west, this is the east, and they are 1 day ahead. So date is 1 day ahead here in the east. And this is the international date line. Now it's March 9 over here. It's March 8 over here. And also the calendar, setting up the calendar, designing a calendar was not easy. Many challenges. Two main challenges are first one, to keep track of time so that you know your birthdays, your anniversaries, religious holidays, religion days. Traditions, culture. There are so many in the world. If we celebrate something today and say, okay, we're going to celebrate it every year. You know, when the seasons change and we are back to the similar seasons. So we have to have, in the written form, we had to write it. Now you just look at the calendar and you see, oh, okay, so it falls on that day and that date. But when you don't have a calendar, sometimes before calendar times, you had to wait for, let's say, leaves to grow back in the trees after winter. And you say, okay, now it's time for that celebration. Okay, that was a challenge. And also, the other thing now, people have understood the astronomy a little bit. This position of the sun, earth, moon, sky, or how seasons changes every year. Now you have to come up with a calendar that everyone can agree on. A more scientific way based on the motion of the Earth, Moon, and the Sun. And so based on all that, a calendar was set in a more natural way with more natural units. And those are day. And of course, day is further divided into hours, minutes, and all that. But that's the more natural unit based on the, again, motion of the Earth, Moon, Sun, and even planets in some cultures. The original Chinese calendars are based on how the Jupiter changes its position with respect to the zodiacs in the sky, and their zodiacs are rooster, lion, tiger, and that's why they call the year of tiger, year of lion, and so on. So the natural units are day, and day is based on the period of rotation of the Earth, solar day. And the other is the month based on the cycles of the moon's phases about Earth. We'll look into that next. How the moon, is bright one night, and over a period of, 2 weeks, it changes that brightness, gets dark, and again it starts to show some illumination, and back to the full moon and new moon, and so on. So based on that phases, we define that as 1 month, and year is the time it takes for the Earth to go around the Sun. So these are all natural events, and so based on this, we can scientifically devise a calendar with day, month, and year. And within that, we also decided to divide the month into weeks, right? Days, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Those 7 days of a week. It does not have quite scientific derivation, I should say, because in the past, Sun, Moon, and 5 other planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, they were visible by the naked eye, and so all these 7 astronomical objects that were shiny and bright in the sky, based on that, we said we dedicated each day to those objects, and for that we named Saturday through Sunday, or Monday through Sunday, whichever way. And we just start with 1 day and rotate that month long, year long. There are other cultures like Egyptian and even Mayan. They had 10-day week, but that would be very hard and long week. Some had 12-day long week. But over time, we came to a conclusion and to have 7 days a week. And here are some more definitions. The period of Earth, solar day, 1 day, the time it takes for the Earth to rotate, that 1 day. The period required by the moon to complete its cycle of phases from new moon to full moon, back to new moon, and between there are other intermediary phases. To complete that phase, it takes 29.5306 days. So there are still complications here. It's not, even number. Like it's not exactly 30 days, right? Same thing with the year. It's not exactly 365 days in a year. 365 and almost quarter, not quarter, almost quarter, 365.2422 days. And now that quarter day in 4 years' time adds up to almost a day. And so we have to add 1 day every 4 years in our calendar because of that fact. Again, the previous fact, the solar day, every day it has to turn 4 minutes more for one to complete 1 day based on our definitions. Again, despite all these challenges, and we need some correction, and that leap year is a correction. We have a calendar which we can follow, which we cannot live without. Our time, weeks, we have semesters that we have designed to make smooth living. That's the whole purpose at the end. The phases of the moon is next, and this is again caused by the rotation of the revolution of the Earth around the Sun, and at the same time the revolution of the Moon around the Earth. And there is Sun fixed somewhere to the right. We can call that. We can set up our Sun here to the right hand side. That's where we receive the Sun, and Earth is here. And so we can so to start with, the only illuminating object, the only object that produces light is the Sun in the whole solar system. Okay, and we do see planets and moon. That's because they reflect the light from the Sun. That's how we see other planets as well. If something does not produce light, then we cannot see it. However, as long as it reflects light, we can see it, because I can see you and you can see me, though even though we don't produce light. The light from the ceiling, and those tubes, they travel, they hit my body, they reflect, and they travel to your eyes, and your eyes interpret the frequency of the light, and your brain interprets that into different colors based on the frequency of the light. And so similarly, the moon does not illuminate by itself, but it reflects sunlight. And so here is a geometrical setup. The sunlight comes from the right hand side here, and here are different positions within a month time. Start with A. Here, this is the position, and the farther ones, the outside moons, are what it would be, what it would look like when you are standing on the near edge of the Earth, nearest distance to the Earth from here. So if person here is standing here, this is the position of the moon, but this is what it looks like, because it's receiving all of the light on the other side. So it's all shadowed. We call that the new moon, or no moon. We don't see moon during that time. And here, when the moon is in that position there, it basically rises with the sun and sets with the sun. So even though it is in the sky, we don't see any illuminated part of the moon, and hence that is a new moon. Now fast forward a few days, and when the moon is in that location right there, a small crescent starts to appear. Rest is all even shadowed. by itself. Again, it's not the Earth's shadow that falls into. Sun is here. We only see some crescent part of the moon. Fast forward here, and we see the first quarter. The moon looks like that. We see only a quarter of it. And that illuminated side starts to increase when the moon starts to, be on the other side of the sun. So here you see we are looking the moon and the sun in the same direction, but as it starts to illuminate, when it gets on the other side, the illuminated part starts, the bright side starts to increase, and when the moon is on the other side compared to sun here, the moon has as the moon has seen from the Earth, it is illuminated all the way, or the one circle of it, half of it, because the other half is on the back side. But from Earth, we do see a full moon. And so at that state, as soon as the sun sets, the moon rises. And so the moon is here, sun is here, Earth is in the middle. And so all of the light falls in the moon as seen from the Earth. That's called the full moon. Okay, please don't get confused that as you see in the diagram here, this is what's happening, meaning at every location here you see the moon is receiving light from the sun and half of it is always illuminated. But it's because of the position of the Earth, moon, and sun, what we see from the Earth is different. Full moon, and then that illuminated part starts to decrease, call that waning gibbous, and reaches third quarter here, and waning crescent, and the new moon. So waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, and waning crescent, and back to new moon, and the moon, completes this cycle. Here, same thing, more continued, the lunar phase. Here I have detailed outlined here for you to review. This thing, by the way, all these notes are available in your Canvas. I just posted this morning. If you want to review, please go ahead and read through these bullet points. And so that's what these are what the lunar phases are. And some more about the moons. Some more definition of sidereal month and the solar month. Similar to the solar day and sidereal day for the Earth, whenever the rotation of the Earth was measured in terms with relative to the star, one complete rotation, and whenever we come in a line with the distant star, that was a sidereal day. We can set the same thing. We can start a moon at some point with respect to some star, and after a month, when it is aligned with the same background star, we can call that a month, sidereal month. But it's more practical to measure the month in terms of the phases, because we see the full moon, half moon, crescent moon every month, and so we use the solar month instead, and that takes 29.5306 to go around. And because of the rotation of the Earth, remember, our sun is not fixed with respect to the whole galaxy. But within our solar system, we can consider sun to be at a fixed reference point, and as Earth goes around it, the moon goes around the Earth at the same time. So as Earth moves ahead, the rise and set of the moon, that time can change by about 50 minutes every day. And there is another important fact, that the synchronous motion of the moon, or tidal locking. You may have heard the term that we don't, the far side of the moon, or we don't see the other side of the moon. The concept is, whenever, so Earth is here and moon rotates, everything when it's rotating, I mean, the other side must come around and we should be able to see the other side of the moon, right? However, due to its synchronous rotation, meaning its rotation time is equal to its revolution time, the moon only shows one face when it goes around.